Today is going to feel very physics-ish. Without all the crazy, there's tons of different things acting on a certain object at a certain time. Without all that craziness. It's simple physics, but it is going to feel kind of, I don't know, plug and chuggish. That's probably a good way of explaining it. A little bit plug and chuggish. So let's make sure that we have what we need from yesterday. Yesterday we wrote down all kinds of stuff from average rate to how to go forwards from position to velocity to acceleration. This is all we could do before because we only knew how to find derivatives, right?
Yeah.
I want to fill in one quick thing though, just because I don't think I've actually written this anywhere in notes. Probably should have. I apologize. If I wanted average velocity, and I'm using this formula, average velocity. What's average velocity? What's velocity? The rate of change of position. So average velocity, we reviewed this in period 1 real quick this morning, so I figured it's not a bad idea just to make sure that you guys see it and not just hear me harp on it a lot. Try not to harp too much, but I only harp on things, guys, that I see people mess up on over and over and over again. Average acceleration, how would I do that? What's average acceleration? What's acceleration? The rate of change of?
Velocity.
Velocity. So it would be v of b minus v of a all over b minus a. Just, you can write it in. We were reviewing motion, or you can just, try to let it like sear your mind. Probably shouldn't say sear. That's more like what the Bible should do. But anyway, I guess it's searing your conscience. Anyway. Average velocity, average acceleration. Let's move on. Yesterday, I got to show you a little bit as to how to find velocity from acceleration. Integrate, true. But what I didn't get to really show you was why the C magically, it's not magic, it's math, but why the C seemed to magically change to V sub naught. Physics people, real quick, what's this whole little sub-zero stand for? Initial, like beginning, or you could think of at. If we are able to say at 4:30 time is 0, or at noon time is 0, or at the beginning of the race time was 0, or in the middle of the race time was 0, if I can make t equal to 0 whenever, then this is why C changed. Because if I'm thinking about the initial, and if I make time equal to 0 at the initial, then what happens to my equation? Well, 0 times A, what happens? So C is the same thing as V of 0. V when time is 0, and time is 0 is initial. So that's why we were able to say, we're just going to make C the initial velocity from now on in motion. And same dealio down here. We were trying to get to position, which might be the double integral of acceleration. That's exciting. But that's Calc 3. We can just say position is the integral of velocity. Now it's too warm. Integral of velocity, I say then is the integral of acceleration time plus initial velocity. Why is there a 1/2? What's going on? It's t to the what? 1. So then I have to add 1 squared, divide by 2, right? Bring down the 2, the 1/2 and the 2 cancel, got it? But why, once again, why did the C magically disappear? You get x of t equals a sub naught t squared all over 2 plus v sub naught t plus c. There's still a c, but what happens? If I say initial again, that's when time is 0. Plug in 0, 0. Plug in 0, 0. Plug in, oh, it's c. So c is really like initial position. That's why there's the magic x sub 0, what's that? My non-physics people especially are like, I don't know. It's just me especially labeling the constant. Does that make sense? From that, did we write down forevers?
No.
That's because the forevers aren't next. Anyway, example. Sorry. I don't even know if you need to write this, guys. You should know it. I'm just reminding. Anytime you read a problem, my ones that are like, words don't belong. I'm sorry, it's life, and they're trying to explain it. But be mathematical in your reading. What do I mean? Be mathematical in your reading.
Think of
There's a nasty
keywords.
word problem. Look at keywords.
Oh.
Translate. Math, you guys have heard that, right? Math is its own language. So read it, translate it. Figure out what's a given. How do I label it in terms of, especially in motion. Now guys, we've done this for related rates. We did it for optimization. We did it for motion the first time. What are you given? Draw a picture if possible. It's not always. What do they want you to find? If they say when, what are you finding? If they say how fast, what are you finding? Velocity. If they say how far, what are you finding?
Wait, yeah.
There's a few different ways of saying it. Distance, yes. I would say change in position. Might be an easier way, but we'll see that in a second. Identify your givens, draw a picture if you can, identify what to find, solve. Read mathematically, my amazing ones. Read mathematically. And when you do that, can't you kind of say like, don't need to read all the a, ands, and thes. Some of you do. But most of you can be like, let's skip that, that's not important. Just be careful what you're skipping, okay? Can I zoom in on the problem? Are we good? Okay. Did I give you the big old nasty paragraph?
No.
No. I translated already. Let me really quickly, just because some of this is from me solving it, my solving it, the first time, whenever that was. It's been a while, I can tell you that much. You were given a constant acceleration, and you were given an initial velocity. You were given a constant acceleration, and you were given initial velocity. Why on earth did I change 60 miles per hour to 88 feet per second? Wait, I did that?
Yeah.
Dimensional analysis, I was building bridges, right? Canceling out the miles, canceling out the hours. I was trying to get it to feet per second. Pourquoi, how come? To match it up with acceleration, good. So I changed my initial from 60 miles per hour to 88 feet per second. They asked me the question when, so I figured out, hey, I want to find t. But what do I need to do now to solve? Figure out which formula, right? Now, there are two ways of doing it. My mathematical ones, if you're like, I want to say no and say I'm not going to memorize any physics formulas whatsoever, I'm going to do this the calculus way, you can. You can say, hold on, wait a minute. Do we even need to worry about position? Do you see anything about position right now? Or distance? Velocity and time, right? Is there an equation for velocity? Yes. And my physics people, you could say, yay, I know it. Or my non-physics people, but you like memorizing formulas, you can say, yay, you just told us it a second ago. True. Or my super mathematical ones, you can say, yay, it's a constant acceleration, so to find velocity, just take the integral of negative 11 dt. You get negative 11t plus c, but c for velocity is initial velocity. You can actually do it mathematically every time. Or you can say, psh, got a formula, plug in acceleration times time plus initial velocity, which is 88 feet per second. Plug in what you know. Now I have an equation. What's the last thing I need to do? Plug in 45. Fail. Nope, why not? It's not in the right. Doesn't have the right units, right? So I have to do 45. Change it. Oh my. 5,280. Might want to have that one memorized per mile. And then 1 hour, 3,600 seconds, right? 60 times 60. I end up with, I think it's 66 feet per second. Someone can double check that. That's what I remember from this morning. So now I can plug it in. All my units match, and I am good. 2 negative 22 divided by negative 11. Go. Dun, 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 dun. Where did the equation come from? Because you can't do anything if you can't get an equation. Where did it come from? The integral, you could say it that way, my mathematical ones, or my physics ones, or physically minded. That's not what I meant. You could just plug into a formula. I'll just go there. do we do B? Life just got a little more exciting. Hey, now we know there's a car. Whatever, I didn't make you guys do the paragraph, not yet. How far will the car go until it stops? Read it mathematically. Read it mathematically. What do I have? Distance. I'm trying to find some sort of change in distance, right? You don't have to necessarily go straight to the symbols. I need to find a change in distance or change in position. Maybe that's a little bit better. When, hold on, what else did they tell me? When it stops. Hold on, be mathematical. Stops, not position. Velocity. It stopped, right? If it stopped, then velocity. Wait, do I have an equation for velocity somewhere? Yeah. So I can go back and pick them up. Here he is. And I can say, all right, plug in a 0. When does he stop, guys? Mental mathers. You got it. T equals 8 seconds. Yay, I'm done. Box it. I have an answer, and I would say fail. They weren't asking when. What were they asking? How far? So how do I use it? Position. I need position now. How do I get position? I can integrate velocity, my mathematical ones. You can say off to the side, position is equal to. Mrs. Delbo totally apologized to me the other day for her little ones. It's pretty funny. I was like, it's okay, we are entertained. 11 halves. We have to be quiet in our amusement. Plus, what am I doing? I totally got distracted. X of naught, X of t. Okay. What did I do? T to the 1 became t squared over 2. 88 became 88t. I have plus c, but we call him the initial. Or, if you're like, forget that, there's a formula I could memorize. All right, fine. The formula would be x of t equals 1/2 acceleration times squared plus initial velocity times time plus initial position. If you notice, it's the same. Hold on.
Okay.
I have 8. He's going to plug into t. But some of you would get really stuck right now and say, oh crud, I don't have what? X of naught. But are they asking me exactly where in space he was to begin with and then he was to end with? Or are they just saying what's the difference between the two? Do I totally give it away when I ask? I apologize.
Yeah.
But how far? They just want to know from beginning to end, how far did they go? What can I do? I can say how far is going to be the x of t minus the x of naught. This is going to be the how far. This is going to be the displacement. I don't really care about where he was to begin with and where he was to end with. I just want to know the difference. I just want to know the subtraction. So I can move this over and say, what's the difference? What's the point, right? Sorry, now I'm going to English. What's the change in position? By plugging in what I do know. Someone amazing, can you plug that in? 64 divided by 2, 32. 32 times negative 11 plus, I don't know, I got lost. I have some calculators. Just get it for me real quick. I don't need to know x of naught or x of t. I just really need to know the difference. If some of you were like, well, you can always make x of naught where he started from 0, you're totally right. You can always have him start at wherever he is, 0, and then just find that. I just want to make sure you understand how far is just like the change in. 352? 352? I think it's feet. Is it feet? Yeah, cool. Oh, is that not? It might not be. Does anybody else back up the 352? Something's funny. The how far or the change in or the difference is just going to be this shabam plus that shabam. 64, 32. 32 times negative 11 plus 88 times 8. I think I got 352 too. I don't know. Now, there's a lot of concept-y things that we kind of went over, right? Let's summarize. Let's summarize. Where is my air? It is so yucky.
Whoa.
Let's summarize stuff, okay? Let's summarize stuff. Guys, there were two different ways you saw me find formulas in the last page. One was the general what is acceleration. Actually, you know what? We're not going to have to worry about a varying acceleration. We're just going to be doing constant acceleration, so we can just say a sub naught. To find velocity, we can just take an integral of acceleration, same thing, position, integral of velocity. But you can also just memorize formulas and keep them in the back of your mind for motion. Both ways work. Are we 39 and 40, kiddos? Is that right? Whew, we're getting close, right? How many forever cards do you have? We're getting there. So you can memorize, or you can integrate, or you can do, I don't know, both. I don't really know how that would look. Down below, let me change something real quick. I'm just going to change a couple of the notation things just to make it a little bit simpler, I think. I'm going to go from A to B instead of T1 to T2, even though technically that's what it's doing. It's going to be from T equals A to T equals B. Seconds, minutes, hours, depends on what you're doing. And displacement can be found by the integral of V of T from A to B, which is the same thing as, focus guys in the back, the antiderivative of velocity is position of the top bound minus position of antiderivative of B minus antiderivative of A. This is what we would have done before for displacement or change in. If we have velocity, we could just integrate between bounds. It's a shortcut. Total distance, if you think about areas and we're making each portion of the areas positive, it's like we're doing total distance. It's all the positive changes or the absolute value of the changes of position.
Sorry, we're actually.
Are we almost there? I think the next page, I'm coming right back, I promise. After you guys finish these two forevers, grab out your motion packet. We're not going to finish the whole thing. Motion packet, I know what, you did that. But we paused on it because we got stuck on it. Motion packet, it looks something like this.
Oh.
Pull him out and turn to worksheet 4. Pull him out and turn to worksheet 4. Pull him out and turn to worksheet 4. It should be in your binder, in your folder. Notebook. I don't think you go so well in there, Nick.
So for the first are both the VSCs like both the VSCs are they the same?
The general results in the specific whenever you're given a constant acceleration, which is all that we're going to have to worry about. Okay, motion packet. Worksheet number 4. Are we almost there? If you don't have it, you can just, I don't know, pay attention. It'll be in the notes. You can find it later with your motion packet. Motion packet, worksheet number 4. We already did 1, 2, and 3 and like examples on all kinds of stuff with 1, 2, and 3. We left off with speed increasing, decreasing. Worksheet 4 is where I'm like, the weird SE things, we can't do that. And we stop. Now we know that SE things aren't SE things, but instead they're what? What are they? Oh, guys, we're so good. I know it's weird and like swampy in here. Hang in there. Maybe it's just me. Worksheet number 4. Here we go. Speed is the absolute value of. You guys got it?
Velocity.
Yeah, easy stuff. We could have started, but I figured since we couldn't finish, we stopped. Velocity, acceleration, if they have the same sign, working the same way, what's speed doing? Increasing. If they have opposite signs, oh, I just gave the answer. Yay, opposite sign, speed is decreasing. Okay, we got that, hopefully. Worksheet number 4, speed is the absolute value of velocity. Speed is increasing if they have the same sign, and then speed is decreasing if they have opposite signs. The thing I really wanted to look at was numbers 4, 5, and 6. Was numbers 4, 5, and 6. We might get back to the examples in this worksheet, but I like the way they explain velocity increasing opposite. I like the way they explain each of these different quantities. First of all, the integral of v of t is an indefinite integral because there are no bounds. It will give you an expression for who's his antiderivative? I lost you all somewhere in the process.
Oh,
Are you still there?
position.
Position is the antiderivative. Don't forget that you will have a
C.
plus c, right? But what do we call plus c for
The initial.
position? The initial whatever. So in this case, initial position. Number 5 is a definite integral because he has bounds, right? So the answer will be, wait. If it's indefinite, I have a function plus c, the antiderivative. If it's definite, I just get a, what at the very, very end? A number. The number is going to represent the change in, change in difference between antiderivative of change in position. It goes through and explains fundamental theorem of calculus. You can see velocity as the prime of position, so that would be FTC. The answer can be positive or, I know you guys could just do this by logic, right? Positive or negative change in position depending on whether that change takes you right or takes you left or takes you up or takes you down depending on your reference system. Then number 6 is also a what kind of integral? Definite. So the answer will be the number. The number represents what happens when I say absolute value of all the changes in position. I'm taking the integral of speed, and when I take the integral of speed, I'm ending up not really caring about right or left. I'm total distance traveled. I'm not really caring whether you're to the right or the left or whatever. I'm caring about the odometer and how far you've gone. The answer should always be positive. Motion packet gone for right now. Well, for the rest of the class. Motion packet gone. Paragraph examples till the end. I'm not going to actually solve them. I just want to help set them up. If I were you guys, actually, no, this is a command. Do not write these paragraphs down. Write down the page number and the problem number. You can go back. We're ignoring that right now. Just write down page 418, number 36, rowing race. Okay? We're going to work together to set this up. Just write page 418, number 36. Do not stress about writing this paragraph down. We just don't have time. Page 418, number 36, rowing race. In the final sprint of a rowing race, the challenger is rowing at a constant speed. I'm the announcer and I know calculus. Of 12 meters per second. At the point where the leader is 100 meters from the finish line and the challenger is 15 meters behind. The leader is rowing at 8 meters per second but starts accelerating at a constant 0.5 meters per second squared. Who wins? Why is the leader speeding up? He's looking behind him, and who's coming fast on his tail?
The other guy.
Because who's going faster at this instant of time? The challenger, right? But he's how far behind him? 15 meters behind. So we need to figure out, well, maybe we don't even know what we're figuring out yet. But let's split it up and say we have the leader and we have the challenger. What do we know about the leader? Huh? What's 8? Come on, think mathematically. The velocity. His v of, I could say like v of 0, right? So it's the initial. We're talking about this part of the race. So we could say his initial, his velocity, whatever. V of t equals 8. And then what's he start doing? Accelerating. So now, at this instant of time, he said, oh crap, and he started speeding up, right? And how did he start speeding up? At meters per second squared, right? How much distance does he have to finish?
Wait, no.
He only has 100 meters to go, right?
Yeah.
All right, break down the challenger for me. What do you got?
12
meters per second.
He's booking it at 12 meters per second. He's given it everything he has, so he can't even accelerate. He's just going, right? So his acceleration is what? Because it says constant speed. Now some of you might be like, speed? You're just saying velocity. Okay, I'm saying going towards the finish line is positive. I don't know if it's right or left, do you? Okay, come back. Some questions you don't have to worry about. How much space or how much distance does he have to finish?
115 meters.
What equation do you think I'm going to use? Velocity, acceleration, or distance? Position. Why? Could I take an integral of a sub naught and get to v of t and then plug in v sub naught, then take an integral again? Yes, I'm going to cheat. I'm going to totally cheat right now and say, you know what? I know the formula really well, and so can you. 1/2 a sub naught t squared plus v sub naught t. That's what happens when you. For these whole distance to finish things, what are we talking about? Just him? Or the change in where he's starting from where he's ending? Can I think of it as like the change in position, kind of? Yes, I know my physics people, you can say wherever he's at right now is x sub naught equals 0. We're starting at 0 from this part of the race. Whatever. You can. Totally. What am I going to do? Plug in everything I know. So I have my leader. He has 100 meters to go. His acceleration is 0.5 time. Wait, I don't know that. Plus my challenger. He has 115 to go. His acceleration is 0. Okay, forget that. Plus, his initial is, this could actually be a distance equals rate times time. Guys, how will I know who wins? Whoever has the least time to the finish line, they got it. Can you cheat and use your calculator and graph the parabola and find the zeros? Yes, or you can use the quadratic formula. We should probably get you that program, huh? Emily?
Why is x of 0 or whatever, why is that not, okay, so like, why don't you have...
I'm not worried about where they started the race. I'm just saying from this point in time, he has 100 to go, he has 115 to go. So I just care about how much farther he has. I just care about the difference. Does that kind of make sense? So I don't have to really worry about, do I really know exactly what mile marker he's at? I don't care. I just know the difference. Kiddos, let's do one more paragraph. Not that one. It's not bad, but whatever. Number 43. Just trying to help you kind of think through the paragraphs. Number 43. A projectile is fired. Oh, stink. With an initial velocity. Hey, they even told me exactly who he is. Ta-da! Fired vertically upwards. That's a positive, right? Because it's pushing him up from a tower 150 meters high. This might be a good one to kind of be like, cannon. Okay, whatever. Okay, so, how long, and that's 150. How long? Guys, help me translate. How long? What did they want me to find? Find? Time. Good. Will it take for the projectile to reach its maximum height? Find time when I have a maximum position. Why am I saying position? I'm talking about height as in how far up, how far down, and technically if I'm saying vertically upward, this is one of those weird ones where it's like, to make it so easy, it's going to like come back and hit the person in the head. Hopefully not too hard. There's one of those in homework. It's kind of interesting. Find t when wait. How do I find the maximum of something? You could find when velocity is equal to 0, the derivative is equal to 0. You could just find the position formula and graph them and find its maximum. Just kind of depends on how much you can use your calculator. But what's going to go on with part B? Find time? Find height. at the time when he's at the maximum, right? Once you find the time, plug him in. How about C? Find how long. I'm doing more time, right? Oh my goodness. When, what's my clue? The projectile passes its starting point. How high would he be up if he's passing his starting point? So I could say when position is 150. I'm just kind of trying to help us think mathematically, because I know the words trip us out. Hey, guys, you know what to do. You don't need me anymore. All right. Hopefully it's nicer outside. Not as smuffish. I'll see you guys tomorrow. We'll keep working on translating. If you guys want the FRQ packet, it's here, but don't stress. We'll work on it.
So does it go through the tower? I mean, no. This is. I know I ask a lot of really stupid questions, but it has to be higher than the angle to not hit.
Well, here's what I was saying. This is that weird motion of it's going straight up, straight down. We'll say the cannon is a little bit projected. Anything else we need to have parametric equations?
고구 먹고 싶은데 전자레인지를
아 근데 별로라 그랬거든. 그런 거면 나도 정말 살아서 힘들었어. 너무 다 더럽고 막
껍질이 깨끗해.
It's like those pre-algebra questions, like Susie buys 200 apples and she walks out.
Can I still get full credit if I finish it after school with you?
Not full, but you can get the half.
Just do it.
Yeah.
But you
So
can
let me
the
get this
knowledge
straight.
that
What's due tomorrow? The one that was allegedly supposed to be due today?
comes from 34.
It was like the one that was 34 or 33. Yeah. So the long one with all I did and I printed it out. It says that the one with the like large numbers, like all this from
When did you
last night.